Okay, so the next thing that we have over here is basically it's basically called the different forms. It's basically we want to talk about different forms of, or the general form of the general equation of a line. And basically if you might have somewhere in mathematics studied basically the general equation of first degree in two variables. So the general equation, so there is something called the general equation of first degree in two variables. Of course, it's a very simple concept, but it has a big name. And that is basically ax plus by plus c is equal to 0. And that, as you know, is the equation of a straight line. Over here in this equation, basically a, b, and c belong to the set of real numbers, and of course, if it's supposed to be a straight line, not a horizontal line and not a vertical line, then a and b are not supposed to be equal to 0 simultaneously. Meaning that if, for example, if in this equation, for example, ax plus by plus c is equal to 0, if a is equal to 0, then you will get by plus c is equal to 0, or basically by is equal to negative c, or y is equal to negative c by b, which is basically some horizontal line. And in this case, basically your slope is equal to 0. Your slope is equal to 0 because well, you have, for example, some horizontal line over here. If this is x and this is y, you have some horizontal line either above the x-axis or below the x-axis. And well, of course, in this case, your slope is equal to 0, and it becomes a horizontal line. If b is equal to 0, then if you have basically ax plus by plus c is equal to 0, now if b is equal to 0, you have ax plus c is equal to 0, or ax is equal to negative c, or x is equal to negative c by a, which is basically some vertical line, for example, over here. And so it's going to be some vertical line, and in this case the slope is undefined. So if you want the slope of the line to be neither 0 or undefined, then in that case you don't, basically a and b are not supposed to be equal to 0 simultaneously, meaning that you need to have ax plus by plus c is equal to 0, and over here a and b are supposed to be not equal to 0 simultaneously. Okay, so that is basically simultaneously. So in that case, then, so the graph of this equation is going to be some straight line. For example, something like some line like this, for example. Basically, this is the x-axis, this is the y-axis, and this line is the graph of this equation. So then basically they call this, if basically this is the case, meaning that if a and b are not equal to 0 simultaneously, they call this the general linear equation, or they call it the general equation of a line. The general equation of a line. And of course you need to know these things, these labels and these basically names, in order, because once you want to talk about this, of course you need to know the names, because these names are known by everyone. I mean, these are like conventions or agreements between everyone who talks about mathematics, or when somebody else talks about mathematics, they refer to the same concepts using the same names. So basically you will need to know these names in order to be able to understand other people, or for other people to be able to understand you. That's basically what these names actually do. Now, we have been talking about these straight lines for a while, and basically what we want to do right now is basically a little bit put everything together, and basically make sense of everything, meaning that basically when we say that you have ax plus by plus c is equal to 0, it can be reduced to different forms. The same equation can be written in different forms, or it can be reduced to different forms, and every form basically gives you different information, different types of information about the line. For example, there is one form which is called the Slope-intercept form, which we have worked with while we were doing the exercises. It's called the Slope-intercept form, and the Slope-intercept form is basically when you have the equation of your line in the form y is equal to mx plus c. We have had several equations in this form. Now, if you make some changes to this equation, you will have it in this form. And so, for example, let's say that you have ax plus by plus c is equal to 0. And if you want to rewrite this equation in this form, you can basically keep your by on this side of the equation and write negative ax minus c, and then divide by b. You will get y is equal to negative a by b times x negative c by b, and then what you can do is that, and then of course you can compare basically. So you can write this equation as y is equal to mx plus c, and so you can, if you compare, then you can say that m is equal to negative a to b, and c is equal to negative c to b. So this m over here is the slope of the line, and this c over here is the y-intercept of the line. And so whenever, for example, you need to know what the y-intercept of your line is, or what the slope of the line is, you can write your equation in this form, and then based on that you can basically compare and find out what your slope is or what your y-intercept is. And or you can remember these two formulas, meaning that if basically you have some line in the form ax plus by plus c is equal to 0, over here your m is equal to negative a by b, and your y-intercept c is equal to negative c to b. And please note that this is a lowercase c, which is basically this c over here, and this is an uppercase c, which is the constant that you will find in the general form of your formula, so of the equation of the line. And of course you can see that over here b is not supposed to be equal to 0. So if b is supposed to be, if b is equal to 0, you cannot basically divide by 0 here. So here b is not supposed to be equal to 0. Okay, so that's basically one thing. Now if b is equal to 0 here, if you have ax plus by plus c is equal to 0, and if b is equal to 0, you can see that your equation becomes ax plus c is equal to 0, and so ax is equal to negative c, and x is equal to negative c by a, which is basically some vertical line, whose slope is undefined. Over here the slope is undefined. And then there is this line also has an x-intercept. This line has an x-intercept of negative c by a. So the negative c by a that you find over here is actually the x-intercept of the line, and the line doesn't actually have any y-intercept because it's a vertical line. It's either somewhere over here or somewhere over here, or even the y-axis itself. So this is the y-axis. It could be the y-axis itself. If basically c is equal to 0, then and b is equal to 0, then you will get basically ax is equal to 0. That means that x is equal to 0. So then you would get your line becomes the y-axis itself, which is x is equal to 0. And so in this case, I think by definition, the x is equal to 0 is the x-intercept of the line, and then you don't have any y-intercept probably. I'm not sure about this, but it must be like that. So this is basically called the slope-intercept form of the line. This is nothing new, but just putting everything that we know together, basically to be able to make sense of the different lines that we come across in, basically to be able to get different information from the lines that we have. There was another form that we also talked about before, and that is called the intercept form. That is called the intercept form. And as you can hopefully remember, the intercept form was x over a plus y over b is equal to 1. That means that when the equation of the line is written in this way, meaning that the coefficient of x is here 1, the coefficient of y is here is 1, then basically you have what the number that you find down here is your x-intercept. The x-intercept, and the number that you find down here is your y-intercept. And of course, the coefficients have to be 1, and this number must be 1. Otherwise, you cannot. Otherwise, you would not be allowed to conclude that these numbers are basically your x and y intercepts. You would have to make changes to your equation so that this number, this coefficient becomes 1, this coefficient becomes 1, and this number over here, or this constant over here, is 1. And then you can take this number as your x-intercept, you can take this number as your y-intercept. Of course, we have some examples to make this clear. And so basically let's suppose that you have, for example, let's suppose that you have ax plus by plus c is equal to 0. Let's suppose that you have this and you want to write it in this form, meaning that x divided by a plus y divided by b is equal to 1. And so normally you should, of course, naturally you should, or logically you should take this c to the other side, meaning that ax plus by is equal to negative c, and then of course you need to, if I divide every term over here by ab, I'll get ax over ab plus by over ab is equal to negative c over ab, and then a and a cancel out here, b and b cancel out here. So now the coefficients of x and y are 1, but this number is not 1. It has to be 1. So to get a 1 out of this, I have negative c by ab. If I multiply it by ab times ab over c, negative ab over c, I will get a 1 by the reciprocal of itself. So I will multiply x over b by negative c over ab, and y over a multiplied by negative c over ab, and negative c over ab, it has to be negative ab over c. Negative ab over c. Negative ab over c. Negative ab over c. And that is again negative ab over c. And so you see that these two will cancel out. ab and ab cancel out. These two will cancel out. b and b cancel out. a and a cancel out. So you will have x times negative a by c plus y times negative b by c. Negative b by c is equal to 1. So this becomes 1. And then what you can do is that you need to take these to the numerator so that they become so that you get your equation in this form. So if I want to take this to the numerator, you know that if I write x times, for example, a, I can write it as x divided by the reciprocal of a, which is x divided by 1 over a. So you can write this as x divided by the reciprocal of this, which is negative c to a, plus y over negative c to b is equal to basically 1. So basically, long story short, you have x over negative c to a plus y over negative c to b is equal to 1. And if I compare this with this equation over here, you can see that basically a over here is equal to negative c to a, which is my x-intercept, and b over here is the same as negative c to b, which is my y-intercept, and that's basically that. So that means that basically you don't really need to do all of this whole thing. Negative c to a, negative c to b. All you need to have over here, all you need to do whenever you have so that was negative c to a and negative c to b. So whenever you have some equation, the general form of the equation of the line is ax plus by plus c is equal to 0. Now if a and b are not equal to 0, and of course if c is not equal to 0, because if c is not equal to 0, then you can simply have this formula over here. You can say that a is equal to negative c to a, which is your basically your x-intercept, and b is equal to negative c to b, which is your y-intercept, c to a, c to b, y-intercept, and that's basically all you need to remember. But of course, and you don't need to do that whole calculation and going through that whole process. But of course, it's not really, it's not really possible to remember these formulas, so you might actually end up going through the process for that particular case where you're solving some problem. And of course, if c is equal to 0, let me basically do a new. And of course, if you have ax plus by plus c is equal to 0, now if c is equal to 0, then you have ax plus by is equal to 0. And of course, you know that this is a line that passes through the origin, because you see that by is equal to negative ax and y is equal to negative a by b times x. So you see that this line is a line that passes through the origin, and well, it doesn't have any it doesn't have any intercept. So whenever your c is equal to 0, that means that the line simply just goes through the origin in some orientation, either this way or some other way, but it doesn't go through any of the axes, so there is no intercept here. So that's basically that. Now there is one more thing over here that we have, which is there was something else that there was some other sort of formula for these lines that we derived. If you remember, we had basically these lines of this line. For example, let's say that we had this line over here, and we said that, for example, if I have the normal or the perpendicular from the origin to the line, and if this is perpendicular and this is omega and this length is c, then I can say that x times x times cos omega plus y times sine omega is equal to p. That way we could write the equation of the form of the equation of the line. So now this is called the normal form. This is called the normal form. And how you can actually use it is that if I call x cos omega plus y sine omega is equal to p, if that is the normal form of the line, that is the normal form of the line represented by ax plus by plus c is equal to 0. So if this is the normal form of the line represented by this equation, or I can say this, or I can write this equation as ax plus by is equal to negative c. If I assume that these are these are the same lines, so then both the equations are the same. I can then conclude that both of these equations are the same, and so the ratio of the coefficients of x and y and the constant must be the same, meaning that the ratio of x over here is, for example, the coefficient of x is a, and the ratio of a and the coefficient of x here would be a over cos omega. The coefficient of b over here of y over here is b, and the coefficient of y over here is sine omega, and my constant over here is negative c, and my constant over here is p. So then these ratios must be equal, because these are the same equations, or basically representing the same line. So what that means is that then you can basically take these, for example, you can take this one with this one, meaning that you can write a over cos omega is equal to negative c by p, or which means that negative c cos omega is equal to a times p, which means that cos omega is equal to AP over C, and there's a negative sign over here. On the other hand, you can write B over sine omega. B over sine omega is equal to negative C to P, which means that negative C times sine omega is equal to B times P, which means that sine omega is equal to negative b times p over negative b times p over c. And these are all capital letters. Now you know that basically in trigonometry you know that sine squared theta plus cos squared theta is equal to 1, because in a triangle if you have a unit circle over here, and if you have some angle over here, theta, for example, then this length over here becomes sine theta. If this is 1, basically, if this is a unit circle and the radius is 1, this length over here becomes sine theta, this length over here becomes cos theta. And based on the Pythagorean theorem, you know that in a right triangle you can write basically the hypotenuse squared is equal to the sum of the square of these two sides. So you can say that 1 squared is equal to cos squared theta plus sine squared theta, which means that, well, the same thing, sine squared theta plus cos squared theta is equal to 1. And that's basically one of the very basic and fundamental things in trigonometry. From this, you usually derive all of the other formulas. So if you can use this over here, meaning that you know that basically cos and sine omega are these things over here. So I know what cos omega is, I know what sine omega is. So then I can write cos squared omega plus sine squared omega is equal to 1, which is equal to negative AP over C whole squared plus negative VP over C whole squared, which is equal to basically A squared P squared plus B squared P squared over C squared, and then that is equal to P squared times A squared plus B squared over C squared. So that means that you can write 1 is equal to P squared times A squared plus B squared over C squared, or you can say that P squared times A squared plus B squared is equal to C squared, which means that P squared is equal to C squared over A squared plus B squared, which means that P is equal to basically plus or minus C over square root of A squared plus B squared. Okay, so now this way you can calculate. So this is basically one thing that you can use in basically while you're using with your lines. And then we said that basically cos omega is equal to negative AP divided by, let me make a screenshot over here. So over here we said that basically cos omega is equal to negative A times P over C. So this is P over here. So I can write this as basically C over the square root of A squared plus B squared, and there is a plus or minus over here, and if I multiply A over here, and the negative is going to be taken care of by these, and you have to divide this by C. So this is basically what you get over here, and so you can simplify the C with C. So that means that cos omega is equal to plus or minus A over the square root of A squared plus B squared. So that is one thing again that you can use. And moreover, we said that sine omega was equal to negative B times P over C. So sine omega is equal to basically, your P is basically this whole thing over here. So I can write it as plus or minus basically C over the square root of A squared plus B squared, and then you have to multiply b over here, and negative is taken care of here, and divided by c. Erase these things, and then that you can simplify this, so you can say that sine omega is equal to basically b over plus or minus b over the square root of a squared plus b squared. So that is again one thing that you can use while you're working with your lines in normal form. And so basically you have to, if you find yourself working with lines in normal form very often, you need to somehow basically memorize these formulas. And so then you can say that the normal form of the equation ax plus by plus c is equal to 0 is basically x times cos omega plus y times sine omega is equal to p, where p is equal to plus or minus, where this p is equal to plus or minus c over square root of a squared plus b squared. Okay, where your p is equal to plus or minus c over the square root of a squared plus b squared, and then you have one more thing basically, for example, and sine omega is equal to plus or minus b over the square root of a squared plus b squared, and cos omega is equal to plus or minus a over the square root of a squared plus b squared. So that's basically the whole story about the normal form. So now we have a couple of examples. We will go through these examples, and then we have some exercises. Okay, so now let's do a couple of simple examples to basically see how we can basically use all of these formulas that we learned over here. Sine omega is equal to this, and p, and so on and so forth. So basically there were basically totally there were only 3 of these over here. The ones that we basically did over here was basically the slope-intercept form, the slope-intercept form, and that is basically if you have ax plus by plus c is equal to 0 and b is not equal to 0, then you can write your equation as y is equal to negative a by b minus c by b, or basically you can write it as y is equal to mx plus c, and so then m is equal to negative a by b, and c is equal to negative c by b. So that is the slope-intercept form. there is another form of these equations which we call the intercept form. And that is basically if you have again the same equation over here, ax plus by plus c is equal to 0, and this time if c is not equal to 0, then you can write your equation as x over minus or negative c by a plus y over negative c by b is equal to 1, which if you compare it to x over a plus y over b is equal to 1, you will get basically a is equal to negative c by a and b is equal to negative c by b, and this is basically your x-intercept, and this is your y-intercept. And also we had another form over here which was called the normal form, and that is basically if you have again the same equation, ax plus by plus c is equal to 0, you can write the same equation as x times cos omega plus y times sine omega is equal to p and over here you can write basically cos omega as plus or minus a over the square root of a squared plus b squared. Sine omega you can write it as plus or minus b over the square root of a squared plus b squared, and p you can write it as plus or minus c over the square root of a squared plus b squared. So we are going to be using these formulas in the following exercises. So I will simply just make a screenshot here, and then we will go to the exercises. Okay. So for example, let's say that you have, for example, you have an equation of a line. Let's say that it is 3x minus 4y. You have 3x minus 4y plus 10 is equal to 0. And you want to find the slope of this line, the x-intercept and the y-intercept of this line. So basically, to find the slope of the line, you do need to write your equation in the form y is equal to mx plus c, and then m becomes your slope. So now if you were to not use the formula, what you would do is that you would basically keep this negative 4y on this side of the equation, on the left side, and write negative 3x negative 10, and then multiply by negative 1, you'll get 4y is equal to 3x plus 10, and then divide by a 4. You would get basically y is equal to 3/4 x plus 10 divided by 4 is equal to 5 divided by 2. And so then basically you could conclude that basically your m is equal to 3/4. If you compare this equation with this equation, then you know that your slope is 3 to 4 or 3/4. And of course you can of course use the formula that we had. Using the formula, we said that when you have some equation in this form, in the general form, the slope of this line, the slope we wrote it as negative a to b. So that means that over here you can write your slope and you don't have to really go through all of this calculation. You can write your slope as negative a to b. Over here your a is equal to 3, your b is equal to negative 4, and c is equal to positive 10. So negative a to b would be negative 3 to negative 4, or 3 to 4, which is basically the same thing that you see over here. And basically to get the x-intercept and the y-intercept of this equation, again you need to basically write it as in the intercept form, meaning that you need to write it as x over a, for example, plus y over b is equal to 1. So now in order to do that, I'm not using the formula. First let's do the equation itself using some arrangements, calculation and algebra, and then we'll use the formula as well. So I can write 3x minus 4y is equal to negative 10. Now your goal here is to have the coefficients of x and y as 1s, and then have a 1 over here as well, and then whatever you find down here in the denominators are your x-intercept and your y-intercept. So if I want to get rid of this 3 over here, I have to divide by 3s, and if I divide by 3, I have to divide everything by 3. So I have to divide basically 1 time by 3, and then to get rid of this 4, I have to divide by 4, and so I would have to divide everything by 4. So I divide everything by 3 times 4, which is equal to 12. So 3x divided by 12 minus 4y divided by 12 is equal to negative 10 divided by 12. And so you would get a 4 in the denominator, you would get the 3 in the denominator, and over here you would get a 5 to 6. So now what you have is x divided by 4 minus y divided by 3 is equal to negative 5 divided by 6. So now you want to make this a 1. If you want to make this a 1, a positive 1, you have to multiply it by negative 6/5. So I write negative 6/5 over here, and multiplied by this whole x divided by 4 minus y divided by 3, and then write it and then multiply the same thing by this side as well, negative 5/6 times negative 6/5. And you see these two will cancel out, and these two will cancel out, you'll get a 1 over here. And now I have to multiply. So you have negative 6/5 times x divided by 4 minus negative 6/5 times y divided by 3 times y divided by 3, and what I would get is basically 4, 2, 6 by 2 is 3, and then 3 and then 2 over here, and you have negative becomes positive. So you have negative 3 by 10, negative 3 by 10 times x plus 2/5 times y is equal to 1, and that is equal to 1. So now you want to, of course, you want the coefficient of x and y to be 1s, and then have these denominators. So you have to use these as a denominator for x. So if you have, for example, a times x, you can write it as x times 1 divided by a. I'm sorry. If you have a times x, you can write it as x divided by 1 divided by a. Meaning that if you have some coefficient for x, you can use it, a times x, you can take your x and divide it by the reciprocal of the coefficient, 1 divided by a, which is the same thing that I've written over here. So now you can take your x and divide it by the reciprocal of this, which is negative 10/3. And you can take your y and divide it by the reciprocal of this, which is 5/2, is equal to 1. So now you can see that your x-intercept, which is equal to a, lowercase a, is equal to negative 10/3, and your y-intercept is equal to b, is equal to 5/2. And that is basically that. Now, if on the other hand you want to use the formula that we derived in the previous stages, what you can do is that we said that the formula was basically the intercept form. In the intercept form, we said that if we had basically ax plus by plus c is equal to 0, then the x-intercept called a is nothing but negative c by a, and the y-intercept is nothing but negative c by b. So you can simply use these formulas over here and not go through that whole calculation that we did. So then your a is equal to negative c by a, so negative 10/3, and your b is equal to negative c by b. So that's negative 10 by negative 4, which is equal to 5/2. And you see that you have the same numbers that we got before. So that's basically, for example, one example where you can see how you can actually use these formulas, and they make your life a lot easier, provided that, of course, you can remember them, because it's not anything, I mean, it's all about just memorization. There is no way to learn them or anything, but if you memorize them, of course, or if you just write them down somewhere in some notebook or somewhere, they will make your life a lot easier. And let's do another example here. For example, you want to reduce the equation into normal form. So you have this equation over here, the square root of 3 times x plus y minus 8 is equal to 0. You want to reduce it into normal form. Reduce into normal form. And you know that normal form is basically x times cos omega plus y times sine omega is equal to p, and find the values of p and omega. We want to know p and omega. So Okay, so now basically the way that they have solved this problem, which is actually interesting, is that you see over here the basically it's not always very easy to get the if you imagine that, for example, your equation is in the form, for example, ax plus by plus c is equal to 0, and if you want to write it as basically x times, for example, cos omega plus y times sine omega plus is equal to p, for example, something like this, then of course you might write this equation in the form a times x plus b times y is equal to negative c, and somehow basically try to, and as you can see over here, you can see that over here you have a negative square root of 3 over here, and you have a 1 over here, and these two are supposed to be, for example, this is supposed to be cos omega, and this number over here is supposed to be some sine omega. So you need to basically somehow arrange these numbers to be in such a configuration or arrangement that you can say that, for example, I don't know, for example, let's say go for 60 degrees. So sine, for example, 60 degrees is equal to, for example, square root of 3 by 2, and cos 60 degrees is equal to 1 by 2. Now, if these two numbers were, for example, 1 by 2 and square root of 3 by 2, then you would write it as, for example, cos 60 degrees and sine 60 degrees, and somehow make some changes to this part of the equation, and then you would write it in the normal form. But it's not always, I mean, sometimes it's even impossible to write your numbers in, to basically to write your equation in normal form. So what you can do is that basically you saw that basically we in the formulas that we found that cos omega was basically plus or minus a over, and the denominator was a squared plus b squared, and sine omega was plus or minus, for example, b over the square root of a squared plus b squared, and p was again plus or minus, for example, c over the square root of a squared plus b squared. So the denominator is always the square root of a squared plus b squared. So if you calculate the square root of a squared plus b squared and divide your numbers in the equation by this quantity over here, usually you will be able to take care of the equation. So basically what you want to do now is basically take your equation. I'm going to erase all of these things. Take your equation, and you see that over here basically your a is equal to square root of 3 and your b is equal to 1. So then basically the square root of a squared plus b squared is equal to basically the square root of 3 whole squared, plus 1 squared, which is equal to basically the square root of 3 plus 1 which is equal to the square root of 4, which is equal to 2. So now if you divide everything by a 2, you will be able to make sense of your equation and write it in normal form. So meaning that you can write this as square root of 3 by 2 times x plus 1 divided by 2 times y minus 4 is equal to 0. And this is supposed to be cos of some angle. This is supposed to be cos of omega. This is to be sine of omega, and this is supposed to be, of course, if you write it on this side, it would be negative p. Write it on the other side, it would be p. So now, some angle whose sine is 1/2 and cos is square root of 3 by 2 is 30 degrees. So you can write basically cos of 30 degrees times x, or basically you can write x times cos of 30 degrees plus y times sine of 30 degrees is equal to positive 4. Is equal to positive 4. And so, based on this equation, you can see that your p is equal to 4, meaning that the length of that normal is basically of that perpendicular from the origin. The length of that is 4 units, and that line makes an angle of 30 degrees with the positive direction of the x-axis, meaning that something like this, for example, some line like this, and then it's supposed to be 4 units, for example, something like this, and then it's supposed to be perpendicular to your line. And so, for example, it would be some line like this. It would be some line like this, and then this is now basically your x and y, and this is the line that you were looking for. So that is basically the whole story. So basically over here now your p is equal to 4, or 4 units basically, and your omega is equal to 30 degrees. Okay, so we have a couple more examples here. We have a couple more examples here. I think we can do these examples without jumping to another video as well. Okay, so the next question that we have is basically you want to find the angle between two lines. So you want to find the angle between the line y minus square root of 3 times x minus 5, square root of minus 5 is equal to 0, and square root of 3 times y minus x plus 6 is equal to 0. And so if you remember, we said that basically if you have we did talk about the angle between two lines, and we said that basically we derived the formula for this kind of situation, which was tan of theta, which was the acute angle between two lines, was equal to the absolute value of m2 minus m1 over 1 plus m2 m1, for example, something like this. So you can write it like this. So that means that if you have the basically the slope of the first line and the slope of the second line, you can put it over here, and that will give you the that will give you tan of theta, and then based on that you will be able to find theta, which is basically the acute angle between those two lines. So we need to find the slope of these two lines. Now the slope of these two lines is going to be equal to, of course, is going to be equal to, for example, if I call this 1 and if I call this number 2, basically number 1 gives me basically y is equal to square root of 3 times x plus 5. Y is equal to square root of 3 times x plus 5. So here m, or let's call it m1, is equal to square root of 3, because this is the same form as y is equal to mx plus c. So if you compare these, you will get m is equal to square root of 3, or m1 is equal to square root of 3. Number 2 gives me basically square root of 3 times y is equal to x minus 6. Divided by square root of 3, you will get y is equal to 1 over square root of 3 times x minus 6 over square root of 3. So then basically the slope over here is, or m2 is equal to 1 over square root of 3. m2 is equal to 1 over square root of 3. So if I put these two slopes in this formula here, I will have tan of theta is equal to the absolute value of m2 minus m1, for example, 1 over square root of 3 minus square root of 3, and 1 plus 1 over square root of 3 times square root of 3, and that is equal to basically these two will cancel out. You'll get a 1, and 1 plus 1 is equal to 2, so your denominator is 2, and your numerator is basically square root of 3 and 1 minus basically 1 minus 3, so over 2, and that is equal to negative 2 over, that is equal to negative 2 over square root of 3 over 2, and that's the same thing as negative 2 over square root of 3 times 1/2. You have the absolute value of this. These two you can cancel out. You'll get negative 1 by square root of 3, which is equal to 1 over square root of 3. Now 1 over square root of 3 is tan of, it seems that it's tan of 30 degrees, because it's either basically, you know that sine of 30 degrees is equal to 1 by 2, and the cos of 30 degrees is equal to square root of 3 by 2. So tan of 30 degrees is going to be equal to 1 over 2 divided by square root of 3 by 2, which is equal to 1 over square root of 3. So what that means is that if tan of, basically if you have 30 degrees over here, 30 degrees, and if tan of 30 degrees is equal to 1 over square root of 3, there will be another angle that has the same tan value, which is basically this angle over here, which is basically 30 plus 100 plus or basically this angle actually over here, this angle over here, because over here you see your sine is positive, your cos is positive, and over here your sine is positive, your cos is negative, but so tan over here would be negative basically. But so basically the acute angle between the two lines, so basically the acute angle, between the two lines is 30 degrees. And as if you can remember, we said that, for example, if you have these two lines over here, these two lines intersecting, you will have one acute angle which you can call theta, and there is another angle that you can call, for example, phi. And you know that theta plus phi, so you can write this way, but I wish I would. Theta plus phi is equal to 180 degrees. I have forgotten what these angles are called, linear, or I don't remember the name, but they are of course equal to 180 degrees. So then phi over here is equal to 180 degrees minus theta. So now if theta is equal to 30 degrees, then phi is going to be equal to 180 minus 30, which is equal to 150 degrees. Meaning that, for example, you can imagine that the acute angle is 30 degrees and the obtuse angle is 150 degrees. So that's basically the situation over here. So we have just a couple more examples over here, so let's finish these as well and then finish this part. Then after that we have some exercises to solve on this and these few concepts. So the next exercise is we want to show that two lines were parallel if A1 to B1 is equal to A to B2, and perpendicular A2 minus B1 B2 is equal to 0. Okay, so I think these are going to take some time. I suppose not. Let's see. So you want to show that, let me do them quickly. You want to show that two lines, A1x plus B1y plus C1 is equal to 0, and A2x plus B2y plus B2y plus C2 is equal to 0. You have these two lines, and we want to show that where B1 and B2 are not equal to 0. B1 and B2 are not equal to 0. You want to show that they are one parallel. They are on one parallel if A1 to A2 is equal to B1 to B2, and 2, they are perpendicular. They are perpendicular if A1 A2 minus B1 B2, A1 A2 minus B1 B2 is equal to 0. Okay, so of course for the first part, basically the lines that you have are these two, and you want to show that they are parallel if they have the same, if basically a1 to a2 is equal to b1 to b2. And of course, if c1 to c2, if this is equal to c1 to c2, then they're basically the same lines. But if c1 to c2 is not there, that just means that they are parallel. So basically this line over here, I can write it as b1 times y is equal to basically negative a1 times x minus c1, and then I can write y is equal to negative a1 to b1 minus c1 to b1. So this is number 1. Number 2, this equation I can write it as b2y is equal to negative a2x minus c2. So y is equal to negative a2 over b2 minus c2 over b2. And there is an x over here, of course. There is an x over here as well. So y is equal to negative a1 by b1 times x minus c1 to b1. And here y is equal to negative a2 b2 to b2 times x minus c2 to b2. So the slope of this line over here is equal to negative a1 to b1. And the slope over here is, let's call it m1 for example. And the slope over here called m2 is negative a2 to b2. And so now so of course you know that two lines are parallel if their slopes are the same, are equal. That means that if m1 is equal to m2, then that means that the lines are parallel. The lines are parallel. So m1 is equal to m2 is negative a1 to b1 is equal to negative a2 to b2, which you can cancel. You can simplify these, and so that's basically a1 to, and you can make some changes here. You can write this as a1 to a2 is equal to b1 to b2, and that is basically what we were looking for. This is of course a useful basically result that you can use in many different situations, and we did use that in some chapter that was basically related to systems of linear equations and so on and so forth for solving those kinds of equations. And the next part that we have over here is basically we want to show that the lines are perpendicular if basically if this is the case. So over here you can write that basically the lines are perpendicular if m1 times m2 is equal to negative 1. So m1 times m2 is equal to negative 1 is basically negative a1 by b1 times negative a2 by b2 is equal to negative 1. You can cancel out these two, and you can write this as a1 a2 divided by b1, b2 is equal to -1, and what that means is that a1, a2 is equal to -b1, b2, or you can say a1, a2 plus b1, b2. It's supposed to be plus. This is supposed to be plus b1, b2 is equal to 0. So that's basically what we wanted to show. So that's basically this one. Now there is only one question left here. Let's do this as well. And that is, you want to find the equation of a line perpendicular to this line, x minus 2y plus 3 is equal to 0. X minus 2y plus 3 is equal to 0. The line is perpendicular to this line. Perpendicular to this line and passing through this point. And passing through 1 comma -2. So if I find that the slope of this line, I will get -2y is equal to -x minus 3. -2y is equal to -x minus 3, meaning that 2y is equal to x plus 3, meaning that y is equal to 1/2 x plus 3/2. That means that here m1, for example, is equal to 1/2. So since the line that I'm looking for is perpendicular to this line, if I take the slope of that line as m2 times m1 is supposed to be equal to -1. So m2 times 1/2 is equal to -1. So m2 is equal to -1 over 1/2. -1 over 1/2 which is equal to -2. So the slope of the line is supposed to be -2, and it's passing through this line. So I can write basically y minus y1 is equal to m times x minus x1. So y minus y1 plus 2 is equal to -2 times x minus 1. So y plus 2 is equal to -2x plus 2. And these two you can cancel out. Y is equal to -2x. And that is the equation of the line that you're looking for. So that's basically that. Now there is some other business here about the distance of a point from a line. I didn't actually see all of this. Okay, so there is some more theory that we will cover in the next video, and then come the exercises. I'll see you in the next video.